Good morning, everyone. We are excited to be here, and this is Kandan Kathirvel from AT&T.
I'm Rodolfo Pacheco.
So we're going to talk about what is AT&T edge computing strategy and what is the OpenStack role in it. So Jonathan actually covered that there are multiple technology being used in the edge computing as of today, and there's a lot of questions around, like which fits into a real world solution. And I'm going to cover the use cases that telco industry is actually looking at, because there's a lot of myth around the use cases when we read the blogs and the news around it. So we're going to actually share what exactly the industry is looking at from the use cases perspective. And also, we're going to show a demo of a solution that we're going to take it to production for the edge deployment. And it is pretty excited. And we use OpenStack in that particular solution, and we're going to show that how we are using it and what are the other components we are using to implement that particular edge solution. So before we talk about a solution, I think it's very important to understand the use cases. As Jonathan mentioned, there is a lot of use cases related to the edge computing. And there was a lot of push in the industry that everybody awares of is that to move the workloads towards a centralized data center. So that's where the Amazon, Rackspace, and other cloud providers, where everybody is moving the workload into that. And the telcos, they had a private cloud, which is basically, again, based on centralized deployment. But most of the telcos also had a deployment in the central offices to support the workloads which are running in the central offices. And that actually brought the scale up to like 100 or 200 plus location. But it is not about like 10,000 plus location that the edge use cases really need. So there is really a 4 type of use cases that industry is looking at from a telco driver perspective. So the number 1 is like IP enterprise services. This is something in an existing service today that is a need more scale in terms of like a small data center, which is an edge compute, to be deployed in the central offices and other wire centers, which is pretty close to the customers. So this use case is like, could also take the devices into the customer place itself. For example, today AT&T, we support a FlexWare, which is basically we deploy in a customer premises. So in this context, like the use case is like a lower node startup cost. This is very important because when we try to deploy a large data center, what we do is like, we have a big control plane, what we call as like OpenStack, Kubernetes, and other things what we deploy, it's really bigger, right? So that could not be accommodated in the small deployments. And that is an important use case that the first bucket actually has to solve. Whatever we're talking about the edge computing, the solutioning has to work for the smaller, low startup cost, a small control plane sort of a deployment. The second part is a technology evolution. In the telco world, there is a technology evolution is happening in terms of like wireless, because 5G is coming up, and the wireline access. So everything is becoming a virtual network function, as Jonathan was talking about. Like everything is becoming an NFV model of deployment. And this technology evolution really means that like we have to start deploying the cloud in the cell towers, in the central offices, and it is really getting very closer to the user. The third bucket is like, that is what the very interesting bucket that everybody talk about is like AR, VR, drones, IoT, robotics. These application really requires like a low latency workload processing, and that's where this new business opportunity come in. This is not just a telco use case, because telco is actually an enabler. If you use on a cell phone or use any type of access like Ethernet or any type of internet connectivity, in order for the cloud processing need to be done, like it has to be closer to the user. And this particular use case is that this is a new business opportunity for telcos and other cloud providers to support this particular application. The third bucket is that, like the telco has the real estate in terms of closer to the user, because they are the one providing the access into the internet or any type of connectivity. So that way, like the third party cloud could be deployed in the telco spaces, which is actually already happening in some context. Public providers are already deploying in like central the telco offices. But the context is that like this would extend the scale, large number of scale. So to summarize, there is really a four benefits, like from a telco perspective, that telco would get out of this edge computing is that the quality of experience. It is very important that, like this context need to be very closer so that this could be supported from edge computing perspective, the quality of the experience that the customer would see. Either they use AR, VR equipment, or they use some edge application in a cell phone, they get a better experience with that. And the right content at the edge that reduces the backhaul traffic going into the central deployment of the cloud. The third thing is what we talked about, that wireless 5G, that is a decomposing and disaggregate access function. And the fourth one is like a better network resiliency. Now we have like a large number of cloud deployment, then you can have workload deployed across the centralized and the edge cloud, and that provides you the better network resiliency. The other context is like, where does this going to be deployed? That is very important to understand. And there is a really important thing need to understand is that, like there is a specific latency need that applications like AR, VR really requires. And it has to be less than 20 milliseconds. The reason is like when a user is using those equipments, in order to have a very effective way of, like looking at that video, so it has to be less than 20 milliseconds. So where does this 20 millisecond comes down? Like, the device itself would take like a sensor or a mobile device that itself takes like 2 milliseconds. Then you have a last mile, like it could also a customer premise that equipment. And then, like you have an access, which is a cell tower, or it could be a wire center connecting to a Ethernet service. And then we have a telco real estate where that is where, like the telco applications are deployed. So by looking at this context, like there is the edge could be deployed in any of these places. It could be in a customer place, or it could be in a telco space, or it could be in a, like a traditional data center, if that data center is very close to the edge. So if you look at the scale, this is where we really need to understand, like the industry was playing mostly on the thousands and tens with respect to the deployments, but now we're really talking about, like thousands and millions of deployment, because we are trying to deploy something into a customer premise that we're really talking about in like millions of deployments. So that's where this edge scale really comes along. So this is a stack that we have prototyped it, and we're going to take into production. This is completely based on open source, and there is really a two-part here. There's one is like the open source, which is already exist, and the second part is that open source, that something we are developing and upstreaming it already. And in this picture, if you see in the bottom portion of it, the control plane is really, we are trying to run things in a container. Even the OpenStack, we are trying to run it in a container. So there was a question, like what we had to do, can I use an OpenStack today for the edge deployment? The answer is yes, and we are already doing it. And we are actually containerizing the OpenStack components, whatever the needed components, and deploying into the container-based platform. And in the top, you can see that we have a ONAP, which is basically providing an NFP orchestration across the multiple edge location. Then you can also see that components like Promenade, Shipad, Dryark, that's something Rodolfo is going to talk about. And those components are the open source components that we are contributing to it. Rodolfo is going to share that link, and he's going to show the demo. And in that, like we are all contributing to it. We welcome everybody on joining that open source, and it is actually also in the OpenStack website itself. Okay. Okay.
So what Kandan was telling was fundamental. We're trying to solve with this demo a couple of the key problems. They're all problems in a sense that are now they're exacerbated, right? We're talking about you go from multiple data centers to hundreds, potentially thousands of locations where you have to manage a cloud. You talk about the fact that those locations are small, so we have to deploy a control plane that is thin. That's the thin control plane. What we've done is we started by introducing OpenStack Helm earlier last year, all the way through Boston. It's now the OpenStack namespace. OpenStack Helm is a way of packaging OpenStack and deployment and life cycle. We demo doing that multiple times, deploying, upgrading, all without interruption to the tenant workloads. But now we're introducing a new under-cloud control plane. It's this idea that you have to manage thousands of these locations. You wanted to do it with zero touch or as close as possible. And you want to be able to manage the life cycle, not only of OpenStack, but what's running below, which potentially is Kubernetes and Docker, the operating system, and some other functions. So that's what this set of components are providing. We have something called Promenade, which is a way of deploying Kubernetes in a resilient fashion. You'll see in the demo that is quite compressed, so hopefully you guys can keep up. We have ChipYard, which is a way everything that's going to happen in this under cloud control plane is going to be exposed through REST APIs. Everything we do will be declared as all the data is YAML artifacts, following the Kubernetes notions of there's different kinds of documents that describe servers, networks, links, storage, whatever. We have DryDoc, which is an abstraction to managing the deployment of the infrastructure, whether that's bare metals or VMs. It's a framework. Behind it, there will be plugins. Today, in this demo, we're using Mass. Could be ironic in the future. We have Armada, which some of you might be familiar with, which is a way of managing the life cycle of multiple Helm charts. If you're familiar with what Helm is a Kubernetes packaging manager tool. It's up in the CNCF space. Armada is a level above. It gives you a way of managing dependencies across many, many charts. And then Deckhand, which is an internal mechanism that we're building to manage interdependencies, layering, and other functions across all these YAML artifacts that come into this undercloud. I'm going to go into the demo, and hopefully we'll... so I've added some slides to try to give you context of what's happening, but the idea is you're starting with an edge node that all you need is a first seed host, whether you have hopefully remote access to it or you deliver that initial software as what we deliver is Promenade package as a container. Here you're seeing as the container is being built, and it gets delivered to this first node. Promenade has a lifecycle process, we call it Genesis, which will run here in a second. And what Genesis is doing is taking that first node and is going to instantiate a resilient Kubernetes cluster of a single node. And then after we do that, it is going to, again, deploy that under-cloud control plane, all those components that we talked about that are themselves expressed as Helm packages, and we're using Armada to deploy it. Kubernetes itself is running on as well on itself. So we have Kubernetes and Kubernetes. And this is just the undercloud. This is just preparing the first server. So now we're ready to deploy this edge node. It also comes with a series of core services like Prometheus and Fluentd. Now, here we're going to see it executing that, and you'll see it come up pretty quick, because I'm sure you didn't want to just watch Kubernetes standing up this under-cloud control plane. Once it's up and running, we now have a way of programmatically interacting with this edge node. Whether it's 1, 20, 4 servers, I can now describe what that edge is going to be, again, through YAML artifacts, which I'm going to deliver through ChipYard, through a REST API. And now ChipYard is going to, the undercloud is going to take that and is going to use DryDoc. Those artifacts describe what you want. What are your intentions? What kind of service you have? Are they controlled servers? Are they compute? Are you bin packing? Are you separating what the servers are for? All of that you describe to these YAML artifacts that get delivered. And now we're going to watch as this stands up the multiple servers in the node. This is all happening through DryDoc at this point. It's all API driven. And that's what you're seeing coming up. So DryDoc is going to take those intentions expressed through the YAML artifacts and is going to, in conjunction with Promenade, configure, stand up the servers, and is going to automatically, they're going to join the Kubernetes cluster with the appropriate labels. Is also going to configure whatever networking. Through DryDoc, we can do complex networking configurations, MTUs, VLAN assignments, CPU binding. If you're running SRIOV, we can go and configure the virtual functions as a PF. And that's what this is showing right now, is coming, it's going to show up the nodes being recognized by Kubernetes. And as they come up, you'll see that we also deploy some things like the components of the CNI, which for this demo, we're using Calico, also using an SDS based on Ceph. All of this is packaged, again, the same way. It's all cohesive. Everything is using Helm. And as they come up, you'll see that it's going to deploy Ceph and Calico components as daemon sets in the right host. And now the nodes are ready. Now we're ready to deploy OpenStack. We said we're leveraging OpenStack Helm, which again is expressed itself to a series of Armada YAML artifacts. We deliver those through the same API that ChipYard is exposing. ChipYard is going to interact with Armada. And some of you might have already seen this. OpenStack will come up on top of this platform. Kubernetes is going to schedule the OpenStack services however we want. And one of the things that we have here is the ability to control at a very fine granular level what kind of resources you are allocating to each of the OpenStack services. And we can even control within each service which functions we want to run. If for some reason there's an agent you don't care for or you don't need, you don't have to start it. Which is part of our contention that this is providing a thin control plane. We can reduce and optimize the resources that the different OpenStack services are using through the overrides that the Armada packaging of the OpenStack services and OpenStack Helm gives us. This is going to come up as it's, like I said, in an accelerated fashion. You saw the OpenStack services coming up, and now we're going to create an SRIOV VM just to make sure it's all working. And here's a VM, the resources, the volumes coming up. And we're going to see, I'm going to log into Horizon. We're going to see how the once Horizon is up and running, we have the servers immediately are properly configured as compute host. We have the VM up and running. And so what we wanted to show you here, one of the things that we deploy is this core set of functions. So like, as I said before, we are leveraging CNCF functions like Fluentd and Prometheus. And we're trying to make the point that because we can control at that granular level the services, we can express the control plane as a service of resources, core, CPU, memory, and maybe, perhaps you don't have to talk about how many servers do you use for the control plane, but you talk about how much resources you require to run in this thing. And potentially spread the control function across the servers, potentially merge the servers so they're no longer for. So in other words, the control planes and the tenant are themselves two tenants that are coexisting in the same servers. For space where you have 2, 3, 4 servers, that might be the right path to do. Here we're just showing you how the Neutron and MariaDB can be running with very few resources. Again, since these are small edge regions, OpenStack itself doesn't require to be a mammoth of resource utilization to function. And here we had a little bit of, okay, so now we're running these things. We're taking advantage of some of the resilience factors that Kubernetes introduced. So let's pull the plug on one of the servers. We deployed this control plane across multiple servers. So we're going to power off one of the servers. And we're going to see how, even though you lost the whole server, you do not lose functionality or access anywhere. The tenant workload will continue to run. The Nova API that you see there in the bottom, we're pinging as this is happening, will continue to run. The Kubernetes, of course, is not impacted. So the on-the-cloud control plane is still functioning. All of this without anybody having to do anything. Of course, we were pulled the plug ourselves. But the idea here is that, again, trying to reach the zero-touch notion, if the server reboots, so you can remotely boot it, and the problem was one of just reboot this thing, you'll see how the functions that are running on that will come back or be rescheduled on this server that failed. Of course, if you need to replace the server, you have to replace the server. And so here we're bringing the server back up, and we have a few seconds. Again, this is all accelerated. You have ways of fine-tuning the way this works, and if you're not familiar with Kubernetes, the way, how quickly it reacts to a node failure, how quickly it kicks things off, how quickly it decides to reschedule things on the server. So there's a lot of configuration you can do to meet your your use case. And this is going to come back up. We'll show you the workloads. We're going to kill a workload in once the server is up. You'll see it'll bring some of the workloads already back into the server, but we're going to kill one of the workloads that was already rescheduled in the other server, and it will come right up in the server that we just restored. And that concludes this demo for the most part. So again, everything we're doing, the stack that we use for this, is all upstream. It's been developed upstream since day one. We have people in this room that are collaborating in some of those projects. We don't have a name for the whole thing combined. They're all individual projects. The one that deals with bare metal servers, Armada deals with the packaging and the deployment. So people can partake, use the individual project that meets their needs.
Thank you, Rodolfo. So in the Boston Summit, everybody had a question whether we can use OpenStack for an edge deployment. And here is the answer, right? So we did a prototype, and we are taking this to production. And as I stated, like this is all open source. So the part which is related to OpenStack, it's already in the OpenStack project. And the parts which are related to containers, we are trying to put that into the CNCF, but it's all exposed. The codes are all exposed. You are welcome to join on this project. So if the solution is already there, what is extra we really need? What are we going to do in this conference, for example? Right? So there are at least 6 areas that we believe that we need to concentrate on. One is we need to recognize that EC is our #1 goal. The reason is that this is a really evolving, emerging business, and as well as the opportunity for all of us, not only the telco industry, but also for the open source communities and all the enterprise. So we do really need to realize that this is really needed, because this is going to be the future of cloud computing. The second part is that zero-touch provisioning is a key, because that's where we are trying to show here that, especially when you're trying to deploy in 10,000 plus location, you really need to make sure that, everything can be automated. So that's what we are trying to attempt with respect to that prototype and the open source, what we are trying to do. And the support mass use scale, this is also very important, because when we talk about 10,000 of location, the whole orchestration, the whole systems control plane need to support that scale. And support modular deployment, this is very key. The reason is that we don't want to actually install every part of the thing we used to deploy in a large data center. We really like to deploy the only thing needed. Even this is applicable for OpenStack, or this is even applicable for any other control plane components we would support, because we like to have it thin. So in this prototype, we really used the whole thinning down of the OpenStack, really running it as it is, but in a container, in a small set of containers in a local deployment. But we also should concentrate on, what could be done regionally, placing regional placement of OpenStack and try to manage the edge devices. And another thing is support new technologies faster. This is very important, because there is multiple communities that are trying to work on the edge. It's very important that we all coming together, because there are things which are developed by other vendors and communities. We need to adapt to it. For example, GPU, FGPA, and there is special hardware that need to be supported on this. And also, it's really important that we collaborate with other communities from an OpenStack perspective. For example, CNCF, ONAP, and to provide a end-to-end solution. And I think this conference is trying to attempt that. And the last one is support integration with edge technologies. That's what the point I was trying to mention, is that we really need to work together with other communities too, to really support the cohesive solution. Thank you for the opportunity.
Thank you.